today's lesson, we will be covering the 7th grade Common Core Standard for the Geometry section, v.5, use facts about supplementary, complementary, vertical, and adjacent angles in a multi-step problem to write and solve simple equations for an unknown angle in a figure. The big ideas we're going to cover are supplementary, complementary, vertical, and adjacent angles. Let's start with supplementary angles. They are two angles that add up together to sum 180 degrees. Straight line, and we add a ray. Let's say that this angle is 45 degrees, but we're not sure what the other angle is. We could write an algebraic equation to show that x plus 45 must equal 180 degrees. We can solve this by subtracting 45 degrees from both sides of the equation and ending up with x equals 135 degrees. We can check our work by taking 135, adding it to the initial 45 degrees, and getting 180 degrees. So we know our work is correct. Think about it. You have one angle plus another angle has to equal 180 degrees. So in our equation, we know 53, but we're not sure of that other angle measurement. Knowing that we have the 53, we would subtract that from the 180 to determine what is left over of the 180, and that would be our other angle, which would be 127 degrees. Again, you could check your work by taking the 170, adding the 53 back in, and making sure that you do get a solution of 180 degrees. Oftentimes, though, we will additionally get algebraic equations or expressions that have been placed into this scenario. So, for example, given this supplementary angle set, one angle is 45 degrees, the other one is 2x. We need to determine what x is in order to figure out what 2x would be. So we would still use the same equation, angle 1 plus angle 2 equals 180. So we have 2x plus 45 equals 180 degrees. Based on our algebraic reasoning, we would subtract 45 degrees from both sides of the equation. We're left with 2x equals 135. Now, we know what this angle is. This entire angle is 135 degrees. In this case, we have the solution for the angle, but if we need to solve for x, we're going to need to split that 135 into two segments so that we can see what x is actually equal to. And we do that by dividing both sides of the equation by 2. When we do this, we find that x is equal to 67.5 degrees. While our angle is 135 degrees, x alone is 67.5 degrees. Okay, so given this situation, we have two angles. They are supplementary as they do form a straight line. And so we're going to write the expressions into an equation that would total to equal 180 degrees. So we have 2x plus 5 plus 4x plus 7 equals 180 degrees. Notice how I took angle 1 and I'm adding it to angle 2. Okay, the very first thing that we're going to want to do is combine like terms. So we have our 2x. Notice how I'm circling the plus in front of the 4x, showing that we are adding 4x's to our 2x to add up to 6x. We then have 5 units and 7 more units, totaling to be 12 units. And that needs to equal 180 degrees. Now we would subtract 12 from both sides of the equation We show that by subtracting. And we are going to get 6x equals 168 degrees. Now, that's shared with 6 parts, shared. So here we're showing multiplication. The opposite of multiplication would be division. So we're going to divide both sides by 6. And we get that x equals 28. So we know that x equals 28, but we still don't know what each of the angles equals specifically. So we're going to go ahead and erase some of this work, just keeping our final solution. Draw that line back in. Okay, now we're going to substitute our value back into each of the expressions. So we have 2 times 28 plus 5. 2 times 28 is going to give us 56. Plus 5 is 61. On the other side, we have 4 times 28 plus 7. And 4 times 28 is going to give us 112 plus our 7 equals 119. When we take 119 and add it to the 61, we should get 180, which we do. Okay, we're going to move on to complementary angles. Complementary angles are 2 angles that when added together equal 90 degrees. So we usually see a 90-degree angle symbolized by a small square in the corner of an angle. And so even if it doesn't look perfect, it's telling you it's 90 degrees, which in my drawings there's going to be a lot of imperfection. So when we split this, if we split it in half perfectly, then we would know that this is 45 and this is 45, and therefore 45 and 45 are complementary angles because when they add up, they equal 90 degrees. But they don't have to be exactly 45 and 45. They could be 40 and 50, because 40 plus 50 equals 90. They could be 10 and 80. So just like with supplementary angles, they're just 2 angles that when added up create a value of a specific number. In this case, complementary means 90 degrees. So here are 2 drawn problems, and in the first one we see that we have 35 degrees and x. Again, going back to how we could write an algebraic expression, we would take angle 1 plus angle 2 and it equals 90 degrees. We would then subtract the 35 degrees from each side of the expression and equation and determine that our value of our x is 55 degrees. We can test it by adding them back together, otherwise known as checking our work, and we get 90 degrees. In the other set, we have 15 plus x equals a 90-degree angle, or total of 90 degrees, I should say. We subtract the 15 from each side, leaving us with the x equals 75 degrees. Here's a word problem that we might see. What is the complement to a 23-degree angle? So we would take it and think about how we have angle 1 plus angle 2 has to equal 23 degrees. Oh, sorry, equals 90 degrees. So 23 goes here, and then we have our x, our unknown value. We're going to subtract 23 from each side, and we get that x equals 67 degrees. Finally, we can get situations where we are given an angle and again told variables as our angles, but we're told that these are complementary, they're 90 degrees. So angle 1 plus angle 2 must equal 90 degrees. If we substitute our angles into the equation, we can see we have 2x plus x equals 90. We combine like terms to get 3x equals 90. So 3 x's are shared with 90, 90 is shared with 3 x's. Each x is equal to 30 degrees, 30, 60, 90. So knowing that, we know that angle 1 has to be 30 degrees. Angle 2 is 2 times 30, which equals 60 degrees. So algebraic expressions can be placed in the part of an angle. They can be put into a word problem asking you to find the complement or the supplement to any given angle. The next big idea we're going to cover is vertical angles. Vertical angles help us find missing angles in a intersecting line situation, but it also helps us because we can apply the knowledge of supplementary angles to an angle. If we already know one is vertical, then we can find another missing angle and then bring in supplementary and subtract. Here's what I mean by that. First off, we can draw two intersecting lines. Those intersecting lines create what we call vertical angles. This angle is opposite that angle. Because those are vertical angles, they are congruent. Congruent is a mathematical term for equal. So, for example, if this angle is 55 degrees, we know that this angle must also be 55 degrees. In turn, we also know that this angle is congruent to this angle because they're also opposite of each other in an intersecting line situation. So they're going to be congruent. But what are those angles equal to is the big question. This is where knowing that a straight line is 180 degrees, and therefore the sum of two angles that form a straight line would be 180 degrees. Here's that straight line, or not so straight line as I draw it. So we know that this must be 180 minus the 55 that we already know about to get the total angle sum, which would be 125 degrees. Then we can jump right across to our opposite angle and immediately know that that's 125 degrees as well. This also helps us when we're given two parallel lines, or a set of parallel lines, and a transversal. This line here is what we call a transversal line. And I'm going to go ahead and fill in some information and state that that angle is 45 degrees. If I know that that's 45 degrees, then I know that the angle right here has to also be 45 degrees because of the fact that they are vertical. Now, I can figure out how much this angle is and this angle based off of knowing the straight line is 180 degrees, and 180 minus 45 has to be my missing angles. So 180 minus 45 is going to be 135 degrees. So straight across, this also has to be 135 degrees. So the adjacent angles, adjacent means side by side. They share a wall. So this angle is adjacent to this angle. And the two adjacent angles in a straight line, as long as they form a full straight line, will equal 180 degrees. And that makes up our supplementary sum of 180 degrees. There are a few additional rules that we'll get to in the next couple lessons. But what's neat to see is when you take that information and you say that here's your 45 degree angles, because of the fact that you say one is 45, the other one has to be 45, you then fill in and you say 135 must be this angle, 135 degrees must be this angle as well. You'll begin learning about So in future lessons, you'll learn about some additional information, such as how to find the alternate interior angle of a given set of angles with two parallel, when you have parallel lines and a transversal, and also alternate exterior angles and what those would be to each other. So you start to learn how from one angle measurement given that you'd be able to figure out all 7 angles that are missing from a set of parallel lines with a transversal. Some of these will be called alternate interior angles, some of them alternate exterior angles, and then you'll learn some additional features as well. Remember that your adjacent means right next door. So here's your line, think of it as a wall, and it forms between 2 angles. So when it says the word adjacent, they're talking about angles that are right next to each other. They do not have to form a supplementary set or a complementary set. They just need to be side by side to be called adjacent angles. In this case, our adjacent angles are supplementary.